Okay, so our next unit is dealing with exponents. So it's what happens when you multiply and divide exponents that have the same bases. Okay, so this first page of your notes are the name of the properties and then the rule in word form underneath it. Okay, when we're done with today's notes, we'll be able to fill in the rule part and then the example part. But we're going to do that at the end because if I do it now, it's just not going to make any sense to you guys, okay? So we're going to review powers, exponents, bases today and cover the product of, the property of a product, exponent rule. So let's get some vocab words first. So a power, what is a power? The power is how many times to multiply the number. Okay, so if we had like 2 with an exponent of 5, so this means 2 is raised to the power of 5, so 5 tells you that you're multiplying 2 5 times to get your answer. Okay, the base is the number that's being multiplied. And then we have your exponent, which is also kind of the same as your power. It just tells you how many times you're multiplying that number. So the exponent is small number with the base. Okay, so if we had 2 to the 5th, that 2 is your base, and then that 5 is your exponent, okay? So we're just going to review to identify your base and your exponent. So your base is the big number, b and b, so 1.2, and then your exponent is 6. Okay, -4 raised to the 5th, just identifying your base, which is -4, and your exponent, which is 5. 2 to the 3rd power, or 2 cubed, is each having a base of 2 and an exponent of 3. Okay, this should be really just a review because at some point in time you did learn about bases and exponents. So you can go ahead and do the practice, and then when you're done, play the video back to make sure your answers match. Okay, so looking at 1.3 to the 4th, 1.3 is your base, 4 is your exponent. Looking at -5 to the 2nd, -5 is your base, 2 is your exponent. 4 to the 6th, 4 is your base, 6 is your exponent. Okay? What does the exponential notation mean? So when you see a base and an exponent, the base is the number that we said is being multiplied, and the exponent is how many times that number is being multiplied. So 1.2 to the 6th power does not mean 1.2 times 6. Nope. It means 1.2 times itself 6 times. Okay? -4 to the 5th. That does not mean -4 times 5. Nope. That is -4 times -4 times -4 times -4 times -4. So it's -4 times itself 5 times. Then 2 to the 3rd does not mean 2 times 3. It means 2 times 2 times 2. Okay, so go ahead and do your practice. What does the exponential notation mean for 1.3 to the 4th, -5 to the 2nd, and then 4 to the 6th? Okay, your answers are 1.3 times 1.3 times 1.3 times 1.3. -5 to the 2nd is -5 times -5, and then 4 to the 6th is 4 times 4 times 4 times 4 times 4 times 4. So just make sure there are 6 4s there. Okay, again, going kind of quickly because this should be a review. Next part says write an exponential notation. So I'm taking 3 times 3 times 3 times 3 and writing it in exponential notation. So the base, that is the number that is being multiplied, so it is 3. Your exponent is how many times is that number being multiplied? 4 times. So then we're going to write that with 3 with a power of 4. Next one, -5 times -5 times -5. Your base is -5. Make sure you have those parentheses. That is very important. And then your exponent, there are 3 of them. So exponential notation is -5 to the 3rd power. Okay, so go ahead and do the 2 practice problems. So your base is what's being multiplied, so that is 1.2. It's being multiplied 1, 2, 3, 4 times. So your exponential notation is 1.2 to the 4th power. Okay, next one. 3/4 is your base. We're just going to put parentheses around that. Then your exponent is 1, 2, 3, 4, 5. So your exponential notation is 3/4 raised to the 5th. All right, so now we're going to get into the nitty-gritty of the rules. Sorry, just trying to, there we go. So you only need to focus on one thing here. All right. So how do I use the product of powers property to solve exponents? So if a property has the word product in it, that means it is dealing with multiplication. Because the answer to a multiplication problem is called a product. So if we did 2 times 3, 6 is the product. So 6 is the product of 2 times 3. 6 is your answer or your product. Okay, so the product of power property tells us we add the exponents if the bases are the same. Okay, and this only deals with multiplication. So if we look at our first one, it says example, write the expression as a single power of the base. So we have 5 to the 3rd power times 5 to the 6th power. So our bases are the same, so it's 5. And then we are adding our exponents together, which is 5 to the 9th. Okay. Next one, -2 times -2 to the 4th. We have the same base, but be careful, this first -2 doesn't have an exponent. But we know from algebra, if there's none, there's 1, so it's technically a 1. So we have -2 as our base, and then we have our exponents 1 and 4. So our answer is -2 to the, fifth power. 1 plus 4 gives us 5. Then we have x squared times x third times x to the fourth. So we have x as the base, and then we could add 2 plus 3 plus 4 for your answer to be x to the 9th power. Okay, so if the base is the same, you're adding the exponents. So go ahead and do practice 1. Same thing as example 1. Write the expression as a single power of the base. So you go ahead and pause the video to do your work and then check back to get your answers. Okay, so let's check back in for your answers. We have 4 squared times 4 to the third. Your base is 4. You're adding your exponents, so we have 4 to the 5th. Okay, 3 to the second times 3 to the 1. If there's none, there's 1. So it's negative 3. 2 plus 1 gives you negative 3 times 3. And make sure there's parentheses because negative 3 to the third is different than negative 3 with parentheses to the third, which we'll talk about a little bit later. Okay, so then we have a to the 7th times a to the 1, so a to the 7 plus 1 is a to the 8th. Then we have n to the 5th times n to the 2nd times n to the 3rd, so that's n to the 5 plus 2 plus 3, which is n to the 10th. Okay, and sometimes they will ask you what the actual value of these are. So this is when you're going to need a calculator, preferably the one I provided to you, the school calculator, so we're all on the same page here. Okay, so say that we have 5 to the 9th power. So sometimes they want to know, what does that actually equal? So I mean, one of the things you could do in your calculator is make sure you do 5 times itself 9 times, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's a lot of room for error in that because we might get confused and not type enough numbers. So what you're going to do is, in your TI 30s, you type in your base first. So you would type in 5. Then if you look at your calculator, diagonal from the 7, number 7, there's an up arrow button. You're going to click that. So that means you're raising it to something. And then 9 is the power you are raising it to. So it should equal 5 to the 9th is a big number. So 1,953,125. Okay? But if we had negative 2, so let's do negative 2 to the 5th, what does that equal? So this one, you need to, if it's in parentheses on the paper, you need to put parentheses on your calculator. So you need to open your parentheses, type negative 2, close your parentheses. Again, looking diagonal from the number 7, it's the little arrow button, and then it's 5. So that gives you negative 32. Okay, oops. So that's how you put these in your calculator to get an answer. If you have a variable raised to a number, clearly you cannot put variables in the calculator, so there is no value for this because we don't know what number x actually represents. So this only works when you have a number base and a number exponent.